Welcome, everybody. I'm so glad to have you join us today. This is going to be a super exciting episode. We're diving into one of the most exciting frontiers in robotics, to be honest, autonomous sidewalk delivery. Many of you have seen these in different cities around the world. We're going to talk a lot more about where in a few minutes. But today, our friends at Serve Robotics are building fleets of delivery robots designed to safely navigate city streets, which is no easy feat, and bring food and goods right to your doorstep. In this session, they're going to show how they're using NVIDIA Isaac Sim to make all of that possible. We're going to see how simulation helps them to recreate realistic sidewalks and neighborhoods, believe it or not, model robots with Ackermann steering, and bring dynamic street life to the sim with cars and pedestrians. I've had a fantastic time in these warm-ups looking at the presentations you're about to see in a few minutes. But the team has been combining high-fidelity simulation with AI training, and Serve is really just speeding up development, improving safety, and scaling that last mile delivery, which, as I mentioned, is a huge challenge. So whether you're a robotics developer, a researcher, or you're just curious about the future of autonomy, this live stream is going to be a great hour. I'm joined here by our very special guest from Serve Robotics. Human, thank you for joining us.
It's a pleasure, Edmar.
It's great to see you, and you have a rich history. Actually, we're going to talk about your bio in a second, but let me just say that Human is a founding staff robotics engineer working on control systems and motion planning and simulation at Serve Robotics, which sounds like a lot of responsibility. Human, before we chat with your partner, can you tell us sort of about yourself and what you're presenting in the second half of the live stream?
Yeah, so in this presentation, we want to go over some of the sidewalk challenges that we see using our Serve robots every day. And we want to give the users and the community some tools to start building the environment and start creating those interesting interactions between the robots and their autonomy software. Yeah.
Amazing. And okay, so I was lucky enough to sit down with your partner who's right now at the conference, right?
Yes, actually, my head of autonomy, Rajesh, and my colleague, he's attending the Actuate conference today in San Francisco.
Okay, so I was able to sneak 10 minutes from his time yesterday, and so we recorded this clip. Really fantastic. He's going to go over some amazing data that I think all of you will be very interested in seeing. While we play this clip back, you are free to use the live chat to ask your questions, post your comments, let us know where you're watching from, and Human and I and our producer Amelia will chat with you guys in live chat while we're enjoying the presentation. We'll see you right after this, but enjoy this great conversation with Rajesh. Rajesh, I'm so honored to have you here with us today. You are the VP of Autonomy at Serve Robotics, and you guys are doing some pretty compelling work that is actually showing real-world use cases for robotics. So thanks for coming on and sharing a little bit about what you're doing. Why don't you introduce yourself a little bit?
Thank you. Thanks for having me, Edmar. Greetings, everyone. My name is Rajesh, and I'm super excited to share what we are up to in Serve and how we are using Isaac simulation specifically to help productionize a robot and get the improvements the robot needs while it's rolling over the sidewalks. A little bit about me. I've been doing robotics for the last 18 years. I've been had a pretty successful journey in robotics across agriculture. I was the first engineer in Blue River Technology, which was an ag robotics company that got acquired by John Deere in 2017.
Oh, wow.
I was the very first head of computation and machine learning, and was part of the core team who started a new vertical called Autonomous Tractor project that went into production in 4 years and was announced in CES 2022. Pretty excited to see both the products that I was working with John Deere and Blue River being in market and generating revenue and doing good for the farmers and for the field in general. After that, I kind of deviated my attention to mobility sector, as the appetite for the complexity of the problems to solve with robotics and the market opportunity at scale was there. And so it was a perfect fit, as they were building 2000s of robots, getting ready for production scale. They really needed to beef up their autonomy journey to make the fullest potential of the market. And here I am, been here for the last 1.5 years. Really excited to see how this technology is shaping up and how the scale is really impacting how last mile logistics is getting worked out.
Very interesting. That's a great history too. Brands that most of us in the world will recognize instantly. And now we're seeing robots that we will recognize too from your company, delivering goods around neighborhoods. So this is super fascinating. All right, I've got your slides up on the screen if you want to walk us through.
Yeah, for sure. And one of the tagline that got my attention to Serve was, why do you need 2-ton cars for delivering a 2-pound burritos? And that's where we have these cute twinkly eyes robot, and these robot has all the capabilities that potentially a car has to do the same 2-pound delivery of burrito to your home. So let me walk you through a little bit about who we are and what we do before we talk about how we use simulation to improve our robot capability. So just for everyone's information, we are one of the largest AV fleet. We are going to have 2,000 robots by end of 2025, and we are already close to 500 plus robots that are operating in real world operations today, which is delivering food for you if you're in certain markets in US. This is our current track record of growth. We are having a 40% quarter-over-quarter growth in our delivery volumes that we are servicing the customers. We are right now servicing 2,500 plus restaurants. There's over 100,000 deliveries that we have completed since Q1 of 2022. And as I said before, there's 400 plus robots, and this number is changing every month as of this day, of fleet of deliveries and R&D that we are having in the fleet or operation fleets.
Amazing.
And this is a footprint of the different geographical areas within US that we have launched. We started in Los Angeles, which was the biggest market and has a lot of neighborhoods that we are servicing. And we quickly kind of expanded to Dallas, Miami, Atlanta, and Chicago coming pretty soon, which is actually in a few days we're going to be launching in Chicago. And there's also additional metro that we are going to be launching end of the year. So stay tuned to hear more about us on where we launch. And there's also additional cities outside of US and within US that are under evaluation on how we can scale further.
Amazing.
This is actually one of the most exciting things about Serve, specifically for me as we are scaling, which is we are actually one of the very few companies who are having the rich spatial data, which is collected from one of the largest fleets of AV in cities. To just give you some stats on how much data that our robots is collecting, we have close to 1 million miles of data that we collect per month while we are doing the deliveries. That translates to close to 170 billion image LiDAR sets per month that we collect, and that equates to close to 60,000 terabytes per month that we are collecting. And not only we collect this data, but we are already actively using this data to enrich our scene features. We build our own HD maps with this, and we are continuously chiseling the robot navigation capabilities by using the mix of 360-degree image data and LiDAR data, which gives us a very strong geometry and motion of how the robot navigates through these environments in urban cities, which is pretty fascinating and exciting because there's much more innovation that can come by doing this.
It's an incredible amount of data.
Yeah. Okay, so to give you a little bit of glimpse on what we are exposed to in a sidewalk ODD, it's actually quite challenging than anyone thinks about. Of course, there's a benefit of speed where you don't have to travel at 60 miles per hour to do your job, but the environment is extremely hard. You have walkways, parking meters, a lot of pedestrians. I mean, in the end, pedestrian is a bipedal robot, right? You can't really predict their movement. And there's also pedestrians driving their scooters and bicycles in a sidewalk. And so now you're actually exposed to a lot more nuances, and more importantly, there's no actual structure to a sidewalk. There's no concept of lane. There's no concept of regulation that like a maneuver in a sidewalk is adhered to, be it a pedestrian or a child or a dog or a delivery robot. We got to set our own rules, right? And that's even challenging problem, because you have to be safe, you have to be socially responsible, and you have to do the delivery on time, which all is conflating problems with each other to do it correctly.
Sure.
And on the autonomy approach, while we have to perceive the environment correctly, there's also a lot of prediction and motion planning and control problem that is very challenging for us, especially the socially responsible maneuver that the robot has to do is a very challenging problem. And that's where we heavily rely on simulation to do the best job for us, because you can actually put a pedestrian and a robot at different scenarios, figure out what the right socially responsible maneuver the robot should take, and really see how it translates to the real world and do the whole 9 yards of the data flywheel. And we are excited to share some of what we do with the simulation today. This is a pretty exciting video that I want to share, kind of what is the social nuances and some of the things our robots get exposed to on a day-to-day. This is one scenario where there's a family trying to take a selfie with the robot. There is a pet that has a love and hate relationship with us. And there is someone trying to, we call it a surfboarding with our robots, which is, there's a lot more that I can share. But in the interest of time, I'm only sharing 3 of these. But this is something very unique to us also. Like you can actually see the social nuances and the socially different experiences that a robot is undergoing on a day-to-day basis. With this, what I want to do is kind of jump into a little bit of how we are using Isaac Sim for our simulation story. Really want to get the community started to think about what does a sidewalk look like, how do you put a robot in a sidewalk, and really start doing simulation with Isaac Sim to understand what this ODD is and what you can do with a robot navigation in a sidewalk. For that, I'll introduce my colleague Human, who's been spending almost a year on this project, and he's a staff engineer with Serve, and he's one of the founding engineers with Serve Robotics. He's been thinking about it and working on this problem, and I'll hand it over to him to share more on what we do with Isaac Sim.
Awesome. That was an incredible overview. So thank you for explaining and walking us through that. Really compelling. And yeah, now we'll switch it over to Human. Thank you. That was such a great discussion. The information that was presented in those few minutes, I thought was extremely compelling. And I think this is one of the things that also people have been very skeptical about, to be honest, right? That a robot could actually navigate these really difficult environments. But as we're seeing, you guys are doing that, not only in testing, but this is actually real world. It's working. So really amazing. And obviously we can see right now in the chat, we have lots of people watching live. Thank you everyone for tuning in. We're seeing a lot of amazing comments, some great questions. So keep those coming. We're going to circle back to those in a few minutes. But Human, thank you so much for joining us again. I know you got a nice little presentation here, so I'm going to bring that up on the screen.
Yes.
Okay, I think we are. Okay, now we see why use simulation.
Yeah, thanks, Edmar, and thanks to Rajesh for giving this nice introduction and getting us started. So one of the things that we can talk about before diving into how to build the sidewalk simulation is why do we use simulation? And one of the reasons is really the complexity of navigation on sidewalks. There are really 2 main streams of work in simulation. One of them is for training basically ML models where, robotics has a data problem. And getting real-world data is not always possible for every company or everyone who wants to get started. So that's why simulation can really come in and introduce that variety and interesting cases that you don't usually get in small test domains. And you can also introduce domain randomization. Like, for instance, you can change the weather, you can change the lighting, and add to your data set. So that's really one angle that a lot of the people in the industry are approaching simulation. And the second one is to really have a way to rapidly iterate on the motion planning and behavior planning algorithms that you have, especially in cases where you have social interactions with people and bicycles and scooters on the sidewalk. And not only that, but you also want to make sure that you are safe and your performance is also good, because like a safe robot who doesn't move, it's also not useful for that, most of the applications. So we want to have a safe movement with good performance around people. So let me dive into the first use case. Here's one of the basically more realistic renderings that we have at Serve, and my colleagues have shown that you can actually put the robot among various kind of dynamic actors, pedestrian cars, and lots of outdoor furniture and things that you can find on everyday life as your robot goes out to the streets. But the second part that is really the topic of our presentation today is to how can you do the simplest form of environment so that you can start working with motion planning and control algorithms. And this is the use case that I hope we can build by the end of this presentation. You can see that here I have a robot in the scene. I have added a pedestrian behind the robot, and we are going to look at the interaction between how the pedestrian would follow and pass this robot. And really, every robotic system would have three main elements. This is the standard in the industry, that you have perception, you perceive the world through your sensors, and you have planning, how would you move the robot among different obstacles, and action. So act for us is, for this car-like robot, is really velocity and steering that you would give to your model of the robot to move it correctly. Here, the main part of the focus is going to be on the environment and the robot, and let's dive right into it. So for setting up the environment and the world, a lot of people would face challenges that it's not easy to get started, but we are introducing a simple workflow that is all open source and readily available for anyone to follow. And we want to show you some of the examples that how can you start simulating on any city that you'd like to use in your simulation. So the first step really is to use the OpenStreetMap, which is an open source software. And I have an example of this open here, where you can search for an address. Here I have picked up a interesting blog from Los Angeles, which we also operate on. And here you have basically different gadgets, but one of them is about exporting. So you can select a part of the map that you are interested in and adjust it to the size that you want. And once you click export, it will generate an OSM map that you can then load in a similar graphical interface that I'm going to share with you. So
this is fascinating, by the way. We've seen a lot of amazing comments along the way here.
Thanks. Yeah, so here, and please feel free to pause me if there's any interesting questions along the way. So this Java OpenStreet editor will allow me to now open that same file that we just downloaded. I have an earlier version. So once you do that, you get access to all the annotations that are part of this map. And you can also add the cartographer map on top of it. So you can see the street names and like really interesting connections between, let's say, intersections, walkways, roads, building, all of that. And if you do need to add further annotation, you have various tools to update this model. But once you're done and you have the version of the map in 2D that you're happy with, you can actually move back and work with Blender, which I have a video to share.
Okay, we'll play that video, and I think it's coming up right now. Here you go.
Absolutely.
Okay.
Right, so here we're showing that Blender has this nice extension, which is called Blossom. That's short for Blender OSM integration. And the way that you can actually take that model of 2D world into 3D before importing to Isaac Sim is using this extension. You should make sure that you actually are also importing the walkways in addition to all the other annotations that are in your map. And once you select import, you can actually get this 3D world. And this really quickly sets you up to have the geometry and the size of the intersections and walkways that you can then put your robot on to do simulations. What we showed was for flat surfaces, but if in Blender, you also have a chance to add elevation, because as you go down the sidewalk, you could also increase your height or go down in height. So those are also possible. So going back to the presentation, I want to show. So now that we had a look at how to adjust the 2D map into 3D, we can actually then import it in Isaac Sim. And the trees here and the cars that we have added are available on Marketplace. You can find any version of vegetation and other details that you'd like to add to your sidewalk, if that's interesting for your scenario. And the second part is really importing your robots. So for us, we have a model of the Serve robot on the right-hand side. And since Isaac Sim 5.0, the importing has been really made easy. So you just go to File, Import, select your URDF, and you'll need to have the meshes available as well for collision detection and also for the visuals. And the import should be really simple. And you would get the USD of your robot in addition to the environment that you have built. So now that we have both of these together, always it's good to do what we call the marshmallow on top approach. You have the environment, you have the robot. Let's put them together and see how would the whole thing work. In this slide, we are showing that you can actually build the action graph, which is having all of those joint controllers for each motor in the robot, and also what we call the Ockerman controller. It is essentially connecting the velocity commands that you are sending from your perceive, plan, act to the robots, and also adjusting the steerings. In this particular scenario, since it's an open loop test, I'm only sending forward velocity just to see how the robot goes over this sidewalk. And you can see that the sidewalk surface that we have created is not also very smooth. The camera is attached to the robot, and that's why when it goes over some of the bumps, we can actually see that. So now that we have talked about Ackermann kinematics, let's dive into some of the details and let the users basically see how would you go from velocity and steering commands into actual motor commands. So this is the diagram of a car-like robot. If you drive your car, you may wonder how does the velocity of each of the wheels or the steering angles of each of the wheels are being controlled. This is all done in your car using the differentials and the mechanisms that are in place. But for our robots, we need to know the relationships so we can actually control them. So if you look at here, there are like several important points to remember. One is that when you're rotating and moving forward to the left, you have a center of rotation, which we call O. And the whole robot, when it's just steering from the front, has a center of movement, which we call B. So once you define these relationships, you can start writing right-handed triangle rules to find the distance of each of these wheels to the center of that rotation. And why do we do this? Because when you are going forward and turning, all of your wheels are not spinning at the same speed. They are actually, the ones that are farther are spinning faster, and the ones that are closer are spinning slower, because they are on a smaller radius. If you imagine each of them are on a separate circle with all concentric at O, they are moving different distances. So we have to calculate them to make sure that the robot is not slipping or sliding to the sides and you're correctly following the commands. And this is the relationship that we have, and we can dive in a bit deeper here. So let's imagine we just take this red triangle. And my goal is to really find this, let's say, steering angle A3. And based on just the right triangle rules, you can see that this A3 is the same angle as this one. And that's complementing the 90-degree angle that you have inside this triangle. And based on tangent rule, you know the tangent of that angle is R4 over L. And since that's the complement, pi over 2 minus that angle, we get the inverse of that, which is the L over R4. And you can actually do this as an exercise at home, where you also try to find the velocities based on these distances and rotation of these wheels. But the good news is that we have made a contribution also to Isaac Sim 5.0, where this code is readily available for you. So if you go on this path, extensions, Isaac Sim wheeled robots, and controllers, you'll see this Ackermann controller. So in older versions of Isaac Sim, we actually had most of these wheels rotating at the same velocity, which would work for simple cases, but it would needed a better accuracy. And that's actually how we collaborated and added this extension. And feel free really to dive into this code and use it for not just like the Serve robot, but also any forklift, anything that has a car like kinematics could be helpful. Right, so now that we talked about the robot, let's talk about the actors. So in the scene, like you saw in the videos, there could be like pedestrians, could be cars, but we want to have a way to really set the scene, make the scenario really interesting for the robot. And the idea that we want to introduce here is what we call the triggered scripted motion. So in this slide, imagine that we have an actor, A, on the side. It could be a pedestrian. And we have the robot on the right-hand side. And in the middle, we want to put a detection zone for our trigger. So the goal is really to have this actor follow a series of waypoints that you would specify, so the positions and the velocity. And you could have a spline library that would fit a very smooth and nice curve to these waypoints. And once the robot comes forward and passes this detection zone, only then we will get the actor moving along this path. And the goal is to really have them cross paths, so you can actually test how does your behavior planning work, how does your motion planning work. Do you like stay safe and keep proper distance with the person? And that could be one of the interesting things that you guys can get started as well. So let me start first by diving into the detection code, and we want to share some code snippets where you can actually code it as well as Isaac Sim extensions. So starting with the Omni graph, you can here see that it's pretty simple code. So you would only get the execution in, and the output of this node is going to be just a detection flag. It would only say, is my robot in the detection zone or not? And we just need one Boolean. And the way to detect that really is using the physics API. And you can see that we just passed the target prim, which is that zone that I showed. And we check that is the length of the colliders bigger than 0? And if yes, we'll just set a Boolean to the output. The whole action graph that we have actually between detection and move is formed as like this. So we talked about the detection part, but now let's also talk about how do we do the move part. So the move part is really going to be basically shown like this. So you need the detection to inform the move to set the pedestrian in correct positions with the right velocity. And what you need really to set this scenario, we have abstracted in this simple form where you can load in your Python API. So starting from the top, we can have different components, which are, in this case, it's the move component, and you can actually have an asset which is available on Isaac Sim marketplace for free. And once you get this adult male actor, you can set its pose in the USD frame. For us, really, the USD frame is based on our environment. For you, it could be different values. So you set the XYZ and the roll pitch yaw. You also need to define what's the size and position of your detection zone. And finally, the waypoints that the pedestrian is going to follow. So these are X, Y, and Z, and the speed that you want the pedestrian to have at that moment. So now the interesting part, now that you want to implement another extension, which we call move, what's involved? The first part is that you really need to like initialize your node with proper triggers and trajectories. So the way to do that is that we read the scenario config files into this code and create a trajectory using a spline. Here I'm not showing that part of the code, but there are a lot of libraries available online where you can have a set of waypoints and you would connect the output as a smooth spline, which is time parameterized. So you can actually call the position and velocity of that trajectory at a certain time. And all of that is loaded in that trajectory member in this class. And the second piece is this trigger piece. And that's what we showed earlier that is only done through that detection zone. So once you initialize this code, you can come and take a look at, in this extension, on every tick of the simulation, you have the compute function always called. This is standard to all the extensions in Isaac Sim. And then we kind of like read the prims. What's the prim of interest, which for us is the pedestrian, and it's also the detection zone. And we run this code only when the trigger has happened. The most important piece that is happening here is that you can see from the moment that the trigger happened, we are calculating delta t. And that delta t is then passed to our trajectory library, and it's giving us a position and a velocity in 3D world, in the 3D Cartesian world. So then we use them to set the attributes of our actor. In our case, the pedestrian. So the pedestrian, we can move it to different locations, but you also need to set the animation correctly. And that's another modifications that we made to the Isaac Sim asset. So the actual pedestrian has not just the idle and walk, but it has sit and other modes. So we simplified it really to these two separate modes where it would stand or walk. And we have a variable which we call walk. That's essentially the walking speed that we set through the code through basically, I have the code in the next slide, and that would set the whole animation moving forward. So if you remember the position that we were getting from the trajectory, here we are using the same position, 0, 1, and the character height, to then set the word transform for our character. And the character is essentially the skeleton root of our male adult asset that we have added to the scene. So yeah, this is the last piece of having the whole animation and the movement of the animation all connected to your trigger and to the robot movement so that you can create these interesting scenarios. And if we take a look at the whole thing, so this box, by the way, doesn't have any collisions enabled. So it's fully transparent in terms of physics. We only check the overlap between the robot prim and that prim. And the whole scenario, if you want to set it to play, would be like this, where you can see the pedestrian is pausing for the moment of trigger. And as soon as the robot passes through that zone, you would get the interaction started. So we have given some time to the robot to actually speed up and move further away, and the pedestrian is actually walking faster behind the robots. And this is one of the interesting scenarios that you can then connect to your planner and behavior to see how would you want to react in this case. What would happen if another pedestrian is coming from the front or another scooter? So you can add all of these things and create really complex scenarios. And yeah, so that's basically the whole takeaway from this talk. Really, I hope that we've managed to set you up to create your own sidewalk, and I'd be happy to take any questions.
Oh, I gotta say first, let me be the first one to say that was amazing. You have such a great way of presenting this technical information. Start a class, sign me up. I think you should be teaching somewhere. What a great way! What a great way to present. And I've been seeing these same comments roll in throughout your presentation here. So really, really compelling, and just a perfect way to kind of explain things in a step-by-step process in a really understandable, digestible way for the devs here. And we've got a very smart bunch watching, and I see a few of them who are very hard to impress. Are very impressed. I'm looking at you, Papa Chuck. So I'm glad you guys are enjoying this presentation. All right, so we have got a lot of great questions and comments. So let's take a look at our producer here has been very helpful throughout and been kind of marking some of these to circle back to. So let's start with this one. This is coming in from LinkedIn. About the testing aspect, how do you handle edge cases and unpredictable real-world scenarios, such as a child running in front of the robot within the simulation environment, which obviously I think we just showed a little earlier in that video clip, those kind of moments that happen.
Yeah, exactly. So, there are various ways of handling that, but based on our presentation today, we are really interested in looking at the motion planning and behavior that you want to have. Obviously, in simulation, you will have no latency. You will have the perfect perception if you want, because you know the exact prim of where the basically child is approaching you, but you could add actually noise on top of that. If your, let's say, perception system has some noise, or you want to just introduce some randomness to the whole scenario, you can do all of that. And really the trick is to try to connect the noisy detection of that child running to your robot to your motion planning stack. Are you going to react in the correct way? Let's say stop, or even go to the side to make sure that you're not introducing any unsafe situation. And that's the perfect way to actually test in simulation, because you don't want to probably test directly in real world, but you can get inspired from the real world to create these scenarios and improve the whole motion planning pipeline.
That's great. Okay,
Sure.
It's super helpful. Thank you for that question from LinkedIn. Another question here about this being recorded. Yeah, I posted a link in the chat, but all of our live streams, no matter which one you're talking about, they're all available on our YouTube channel, including this one. So as soon as this one wraps up, you go to our YouTube channel there and you'll see it. And the live chat will show up, I think, within a day or so. So you might not see live chat right away, but you'll see the presentation. So thanks for that question. Okay, well, here's one. This looks like it might be a tough case here. Have you ever tried delivery in Indian cities? Where maybe a little bit more chaos.
we haven't actually. That would be very interesting to try. So this year we are really expanding to multiple cities in the US, and I hope that in future we would be also trying out cities in India and other parts of the world. But I think the cases that I think you are referring to should be very interesting in terms of interaction between robot and the people.
Yeah, absolutely. And I think your work on this is proving very valuable in that space. So it's super exciting. All right, we've got this other great question here. And this is fun. This is more about the psychology of people interacting with robots. Is it true that adding the eyes to the robots changed how people reacted to them in LA?
I have seen personally that the reaction of people to the robots, just seeing that they have these nice, cute eyes in front of them changes. A lot of them, as you saw in the video, stop to take selfies. Kids really love them. They come and play with them. And it's really nice to see that, like, that positive reaction from many people. Yeah.
And our producer Amelia shared this in our warm-up the other day, but she noted that she's got her kids are really cute, but they're really young. And one of them was really excited about seeing one of the robots in a recent trip that they made and delivery. And what even made it more interesting was that, and we just confirmed this yesterday, because she thought that he noticed that it had a specific name. And then we talked to Rajesh yesterday, and he said all the robots have unique names, names that people person names. I don't know if this robot was called Daniel or something like that, but yeah, to add on to that comment, I think that also really probably helps the relationships that people are having with your really
Yep, exactly.
robot.
Like the robot behind me, you can see this one is called Hank. It's not doing deliveries right now, but we keep it in the office for basically testing.
I love it. It's great. Okay, so let me see. Here's a question coming from YouTube. I'm curious how we can make robot deployment more scalable in the real world. I mean, I guess all this work is going towards that, right?
Exactly. So there are the scalability definitely is a great question. So to be scalable, you want autonomy to succeed in every corner case. And it's not really easy to basically do real world testing in all the conditions that could happen in the real world. You could get inspired, but you need to have, let's say, simulation tools where you can create thousands of cases. And since the code is basically being updated very rapidly in a really fast iteration loop, you want to make sure that you're not regressing on any of these safety or performance metrics. So once you basically set up a simulation scenario that is testing your code against the physical world, then you could actually spin it up in cloud as part of your CI workflow, and you could be testing your software against n number of scenarios every night. And in the morning, just come and check what tests have passed, what has failed, and have a chance to, even before putting the robot out there, to fix them right at the moment that the error was introduced to the code.
Okay, that's super helpful. I got a follow-up question from Abim here from YouTube. So this is great. We try to shy away from these tough questions because these are really helpful to developers, I think. So from my experience with Jetson, NVIDIA Isaac Lab, and related research, the main limitations seem to be around battery life, Wi-Fi, and general deployment constraints. Is that true to your experience right now on your robot, or are these things you've kind of tackled nicely?
Yeah, so I can imagine connectivity could be an issue, but for us, battery life, these robots can last the whole day, come back to office without any issues. They have been specifically designed to withhold enough energy. In terms of Wi-Fi, we actually use LTE in the cities where we operate, and we also have one of the best teleop stacks where it can use really low latency teleoperation in cases where we need to connect to the robots. However, the majority of time, these robots are doing deliveries autonomously. And but I can hear you that both of these things could be challenges on getting these robots out into the cities and real world. Yeah.
Very cool, man. We're seeing some nice use cases right on your website here. So I pasted the link earlier, but this is just serverobotics.com. And I learned a little earlier today, they are hiring some developers out there. They're really interested in this type of work. Take a look to see what Serve is looking for. Here's a great question from LinkedIn from our friend Glenn. How well does digital simulation stack up against real-world training? Is the fidelity between these modes sufficient, or is physical training still necessary?
So I think physical data is something that you cannot put aside. You always have to combine part of your training with physical data. But the goal is that you can create really high fidelity with high rendering results from simulation to get your ML models started, especially on those corner cases where you don't get a lot in real world. And once you have that ready, you can point the trained model in simulation to the real world and then let it get better and better over time. And this whole loop can continue. You can learn from the real world, add to your simulations. And I think fidelity is definitely a good question. You could see, like in the first tool that I saw, the focus was ML model training, and the quality of the cameras and other sensor information was very close to what the robot sees. That actually can really help to get the models up to speed to be performing in real world.
Very cool. Well, and a quick note for anyone who came in the middle of the live stream. Thank you for joining us. Today we're here with Serve Robotics and exploring how they're building and testing autonomous delivery robots, leveraging NVIDIA Isaac Sim. We've been looking at realistic sidewalk environments, Ackermann-style robot models, and how simulation speeds up safely that last mile delivery challenge that a lot of companies are fully aware of. We have a great member of the community is watching, Tom, or AKA Dylan, as is also named, but he's asking, is Serve Robotics using data collected in delivery to build digital twins of cities for 3D mapping and training later?
Well, I can say that we are involved in that type of project, but to exact specifics, I'm not sure if I can share, but I would be happy to chat offline via LinkedIn or any contact. But that's actually a good question, and that could be one of the unlocks on building environments from real world data.
Okay, cool. Thank you for that question, Dylan. Okay, here's another question from LinkedIn. Are you guys using ROS?
That's a good question. I think the ROS versus any other sort of middleware was also a discussion yesterday at the conference in Actuate, and there's a different aspects to consider: latency, real-time performance, but also the ease of getting started. So I cannot directly comment on the middleware, but I can tell you that if you are a hobbyist and you want to start building your own robot, ROS is a good starting point. It has lots of tools, and ROS 2 has made even some of the real-time issues of ROS improved. You just need to, I think, set the correct configurations to have the network latency reduced and get the performance that you want. But I would say ROS is definitely a very powerful tool for everyone to get started. Yeah.
Good advice there. This is coming in from LinkedIn. Mohammed's asking, where can we find the OSS workflow you mentioned? I think we're going to try to share the deck also. We've started a Discord thread on this live stream, so you can continue the conversation there after we end today. Everyone watching, you can go on a Discord server. I pasted the link earlier. So we'll share the deck there, I think, a little later. But also, what do you have to say to Mohammed now?
Yeah, absolutely. I'd be happy to share a version of these slides and follow up on Discord on LinkedIn to answer questions if you face any challenges following the steps that we shared.
Amazing. Okay, and some of these questions came in while you were early on the slide, so you may have answered already. So just let me know if you kind of covered it. This comes in from YouTube from Edson. Hey, Human, the math and other physics dynamics are also used for the controller in simulation?
Yes, so Isaac Sim is one of the tools that has got good contact dynamics, especially for wheeled robots, and we are using them. So we are setting the correct mass and inertia for our robot to get that interaction also with non-smooth sidewalks. But you could always improve on the contact dynamics, but it's a starting point. So you can look at the slipping and also like going over bumps. So those are included in Isaac Sim, depending on the environment that you are building, this type of the sidewalk. Yeah.
I mentioned this community member earlier, so I've got to show his question. Here's some from Renan, aka Papa Chuck, on our community Discord. By the way, he's actually a very active member of our Isaac Sim and Isaac Lab study group we have every week on our Discord, which takes place every Wednesday at 12:30 p.m. Pacific. We post a link in the chat, but if you're interested in these topics, first, like and subscribe to this channel and this video. That's super helpful for us. Lets us know the type of content that would be great to provide more of. And then come over to the Discord server and jump into our study group that is run by the community members. They have a great time sharing tips and tricks and going over some challenges and how they've been overcome. But this question is from one of those members, Papa Chuck. Let me show it on the screen here. Did you get the ragdoll physics working to simulate pedestrian collision? I guess he's asking if you're showing what happens after the collision. And that's a yes?
Yes, so yeah, we've had basically the physics modified, and we can get collisions with the robot if we want to like check those scenarios too. But the animation also was, needing some updates. That basically those are the steps that I shared. Yeah.
Okay, cool. And I'm jumping around a little bit, so don't worry if you asked your question earlier, I should be able to get back. It's a good question from Jean-Paul here on YouTube. Great presentation about the workflow for building environments. Have you tried NUREC to build photorealistic environments?
Yes, so NUREC is definitely a great tool. I think it really depends on the type of sensors that you have, and I think we are also looking at that option. Yeah, so it's definitely great call out to go directly from real robot data to scenarios. That is the next step.
Okay, here's an interesting question I'm curious about myself. Is Serve thinking about doing drone deliveries in the future? I imagine that the challenge is very different, but have you guys looked into that?
Well, I can say that we have had a partnership with Wing. I think that we were basically filling up part of the delivery so we could cover long ranges. And the video should be available that you can see that we had a multimodal delivery system where the robot would take the food from areas that the drone cannot land to the designated location, and the drone could take it off to where it needs to go. But the robots are operating in really congested areas in downtown LA and many other big cities, and those areas are not usually good for drones to come. And that's why actually the sidewalk delivery, is covering majority of those delivery cases.
Very good to know. And speaking of great developers out there in the world, here's one of my favorites, John Mitchell from BMW. Actually, he's one of our Omniverse ambassadors. Is your fleet management tool proprietary, or are the robots agnostic? Can I use them on any fleet? If you're familiar with that.
I know that we are. This is a proprietary tool that we have built in house, and so we have a dedicated team working on that. Yeah. Okay,
that's awesome. Thanks for tuning in, John. Here's a question from LinkedIn. Have you been able to negotiate the use of bike lanes? If so, how has this changed your approach? From Ron.
Well, I would take the second part of the question. Since we are also investing heavily in AI models, once you train them to do sidewalks, it's not a lot of work to basically change that learn methods from sidewalk to bike lanes. But in terms of using the bike lanes, it could come down the road at some point. But right now, I think our main focus is the sidewalks. Yeah.
Okay, here's a cool edge case here from Izzy on LinkedIn. Let's say a bird or a cat runs in front of the robot, from object, bird, animal, entering the frame to the driver sending command to stop the wheels. Time to calculate and recognize the object. Time to send command to stop the wheels. You guys have obviously done a lot of this work. Is that that's something you guys have obviously been dealing with the whole time, I'm assuming, right?
Yeah, so I think if I want to understand the question correctly, is basically he's talking about a sudden interaction with obstacle, could be bird or pets that were not seen before, and you want to basically able to safely maneuver around them. Yeah, so we do see a lot of those things. Because on sidewalks, you can expect anything to happen, actually. And one of the main things is how do you make sure that these robots can stop on time, see the moving obstacle, that's coming out of a blind spot or behind the trees on time. So we have a pretty, I think, robust perception system that is detecting them with low latency, and that sends these basically messages to the motion pipeline to react accordingly. So yeah, that's definitely a concern for lots of AV companies to see fast moving objects at the low latency and to be able to react. So yeah, that's definitely one of the good things to add. Yeah.
Great insight. This question is coming in from YouTube. For the trajectory, did you use mostly hard-coded rules or reinforcement learning?
Well, this was a kind of a getting started point where we just wanted to say with a prescribed trajectory, how would you react to a person? So because you want to create that interaction. But reinforcement learning, I think, yes, it is picking up a lot of interest from everywhere, and there's like already a conference, I think, going to happen soon on that. So that would be also very interesting to show how would you move your actors with an agent that is connected to reinforcement learning. Yeah.
Okay, here's a question. It just came in. What processor do you use for local real-time processing of data?
So inside the robot, we are using the NVIDIA's GPUs, and that essentially produces a lot of power, compute power, both CPU and GPU, that we can run all of these nodes inside the robot. Yep.
Yeah, I figured that was going to be the answer there. Okay. Let me see. How do you identify the commands for traffic light when they see one, they need to cross the street? I guess
Yeah.
These traffic signals are probably a big part of your approach.
Exactly. So moving from block to block, essentially you need to monitor traffic. So you need to know when is the safe time to cross with pedestrians over the intersections. Yes, so we do have a specific cameras that can zoom into like all the traffic signals, and through ML model training, we can actually identify when is the green light, when is the red light, so we can kind of adhere to all of those rules. Yeah.
Very cool. It is an interesting question about protecting the robots from hacking or malicious use. So you want to talk about this at all, or?
Sure. I would say there's multiple different angles to this question. So in terms of probably hardware, I would say that these robots have been operating in Los Angeles, which is a really crowded and difficult environment with really good reliability, and but on very accidentally. On some very cases that we see, there is like good SOPs in place to handle them, but overall we don't see a lot of basically we see a positive reaction from the people in different cities. Yep.
Very cool. I'm gonna show you a slide back on the screen here for the takeaways. Okay, cool. And we have another question from LinkedIn. How is the speed variable calculated, and how is it synchronized with the animation to prevent visual artifacts like foot gliding or unnatural movement?
Yeah, this is a good question. So in the code snippet that I showed, the animation speed was set to a constant value, but you could actually set that speed also from the trajectory that we were producing. So if you go back in the recording later and check the trajectory that is called at a specific time, it sends you the position and the velocity, and you can actually set that to the animation. There's a snippet slide that shows the animation, how to set that speed. And I think that should basically get the job done. Yeah.
Okay, great. Let me see. We have a follow-up question also from Gobel, who we chatted with earlier. How does the code shown in the image relate to controlling a robot's movement and detection? He's talking about one of the earlier slides, obviously.
I'm not sure which slide.
We might need to ask him to clarify which image it was. But that's a good question to follow up on Discord, Gobel. If you wanted to take a screenshot of that part you're talking about in the video and just post that screenshot and ask your question in the Discord thread, we will help you there. Okay, Gobel has a follow-up here. What is the purpose of the move curve and detection nodes in the action graph you showed earlier? Can you explain the high-level steps involved in setting up a robot simulation in Omniverse? That could be a big answer, but
Sure. I mean, the first part we almost covered in what we wanted to do. So we want to introduce a type of interaction that you control. You want the robot to move in a certain way, and you want also the pedestrian to move to cross path with the robot. So for instance, probably this slide is the best one to talk over. So if you, let's say, just introduce randomness to the movement of these actors using, let's say, reinforcement learning that came up in the discussions, you don't have exactly the way to ask this agent to pass through this path. You could introduce randomness, but this was a starting point for us to say what would happen if a pedestrian is coming towards the robot and crossing path at a certain speed. And you could add more actors in the scene to create this challenge for the robots. So I think getting control over how the agents move based on how you want them to move is the main reason that we introduced the move curve.
Well, that's super helpful. Again, really great presentation, and also to our viewers watching and asking questions and comments, fantastic your participation throughout this live stream. These comments and questions are really what make these live streams so fun to do. Speaking of fun things to do, GTC DC is coming up at the end of October. I'll be there. Are you going to go? I hope you can make it. It's a really fantastic time and a great opportunity to not only learn a lot from different sessions. All the labs, I think, actually are sold out, but there's lots of sessions available. Lots of great networking opportunity with a physical AI day, a meetup. I'm going to be making my schedule available for coffees every morning and meeting up with people for lunch. So I hope you're able to make it. With that QR code, we'll give you full details on the session. Even if you can't make it, it's a great opportunity also to see Jensen speak. He's going to be giving a keynote for the first time in Washington, D.C. That keynote will be available worldwide, so you can live stream that, watch in real time. But if you're there, you can watch it in person also. So really amazing content planned with great sessions and speakers, and the networking opportunity is you can't really I can't state how impactful it is to developers who attend these types of shows. As Humana actually and his partner Rajesh are learning right now at their conference they're at. We have, as I mentioned, Physical AI and Robotics Day at GTC DC. Their QR code will bring you information in there. I'll be hanging out. I'm going to be recording a bunch of clips. A lot of people out there enjoyed the clips we shared from the last conference at SIGGRAPH, so we're going to do the same thing and try to make it as informative as possible. People who are there, but also people who can't make it, and we give them some insight each day from the floor. We also have sessions focused on industrial AI and manufacturing. That QR code will bring you there. And I thought there was another slide. Oh, and we have a GTC DC WhatsApp group. So if you are attending, this QR code is for you. So we actually have a nice little group. It's on my phone right in front of me. So you can actually engage with not only me and our producer, Amelia, but other people who are attending GTC DC. So you can make plans, talk about what your goals are, give some background on your company. And I've seen so many great relationships happen just because of this WhatsApp group we have. And I shared this last week, but just a reminder that our OpenUSD sessions from SIGGRAPH are now available on demand. So if you didn't make it to SIGGRAPH, you can actually check all these sessions out. And man, I hope you guys are paying attention to this one, because I would love to have your work shown off at an upcoming event. And that's what this is all about. So if you are using the physical AI data set that's available on Hugging Face, and it's been impactful, maybe it's removed blockers or made things quicker, or just enabled you to do things that weren't possible before, please tell us. We want to share your story with the world. So you could be included as part of an upcoming presentation or video at a widely watched event. So leverage that QR code. If you miss it, just ping me on Discord. I'm EDMENDI on Discord. Speaking of which, here are QR codes that are bringing you some of the community resources we've got. That first one is for our Ed Events calendar, which makes it really easy to subscribe and see all of our events upcoming. These events include live streams like this one today with Human and Serve Robotics, which has been fantastic. This is listed on our events page there, as well as upcoming live streams are some really great ones coming up. I have to tell you, Amelia and the team are working hard and bringing some excellent content. So you can check out those as soon as they're official. They'll be announced there. You can also look at the upcoming office hours, which is basically an hour where we'll answer questions in real time focused on specific tech like Isaac Sim or Isaac Lab. We also have our study groups are listed there. I mentioned earlier, we have one starting in a half hour from now every Wednesday on the Discord server. And then we have, if you need official support, go to our forums. That's where our team can track everything, and we can assign a developer to your issue. And then that third link goes to our Discord. We hope all of you are members there already, and you've introduced yourself in the introductions channel, and you're leveraging some of those channels to help you work. And our community page is that last link, and where we list, I think one of the most important things on that page is a list of our ambassadors. You can learn about some of the people in the community we have acknowledged to be really just fantastic developers, people you should listen to, people who are great to work with. And maybe that's you, actually. So if you are an expert in Omniverse or OpenUSD in one or more areas, let us know. We would love to be able to celebrate your work and help put other people in contact with you and maybe give you a good speaking engagement. So I hope that you take us up on that. Human, I can't tell you how informative, and again, what an amazing manner you have in presenting material like this. Like, I can't wait to have you on again, and I can tell by all these comments coming in that I'm not alone in this. There's lots of great comments. We have many people watching live right now. So, if you were going to leave the viewers and developers out there who are either just diving into this or they're experts already, what would be your words of wisdom that you want to impart with, that you hope people take away from watching today's hour?
Yes. So first of all, it's been really fun, Edmar, doing this podcast live stream with you, and really appreciate all the interest and the questions that the users and all the attendees posted to the channel. It really warmed up the discussions, and I'm happy that, I was able to contribute. In terms of takeaway lessons, I would say probably when you're starting with a project, no matter how complex it is, it's always great to start small and build up on that, sort of the marshmallow on top of approach that we use at Serve. And that brings up a lot of opportunity for you to learn and make sure you have a strong core foundation that you can then build outwards to include more and more challenging cases. Yeah.
I love it. That is very wise words indeed. And thank you, Amelia, for reminding me. We also have another amazing event happening in just a few days. This is NVIDIA will be at Coral, and lots of great work on humanoids. It's going to be taking place in Korea, South Korea. So I hope people who are in the area are able to attend. We also have a WhatsApp group for Coral attendees. Even though I won't be there in person, we're going to be helping from afar. So we want to help you the same way with the GTC DC attendees. If you need any help on any sessions, suggestions on which ones to go to, if you need help meeting a partner or someone at NVIDIA because of maybe they can help you with something you're working on, or you maybe need an introduction, or maybe you're a startup, you want to talk about our startup program, Inception, definitely check out this page. We'll put it in the link in the chat and also include in the video description. But amazing content being prepared at Coral just a few days away, including this great keynote on humanoid robotics. Lots of workshops and papers will be presented at Coral. So I hope the people out there who in that region are looking to attend. The other thing, a great resource I should mention also is the LinkedIn group for NVIDIA Omniverse. We have almost 3,000 members there now, which is a very healthy number of developers that are engaging there and sharing their use cases and questions. So if you're on LinkedIn, go ahead, feel free to follow me. I always share a lot of news from the community, specifically on Omniverse and robotics and OpenUSD. So if you just want to follow up with those news announcements, you can just follow me. But definitely follow the LinkedIn page for the NVIDIA Omniverse group and join that. It's a great place to interact with people like Human and other companies that are members already. This has been a fantastic hour. I want to thank everybody for joining me today. I'm going to close out with a short video going over Inception. If you are a member of a company that's a startup, Inception is an amazing resource that everyone really should take advantage of because it's basically no strings attached, free resources, some of which include cloud credits and access to investors. You can watch this video and get more. But thank you everyone for watching, and thank you, Human, and thanks to your partner Rajesh. Let him know we said hello and have fun at the conference.
Yeah, absolutely. Thanks, Edmar.
Okay, and here's the Inception video, and then we'll close out.
NVIDIA Inception is partnering with thousands of the world's most innovative companies, startups at the forefront of AI, data science, gaming, and other breakthrough industries. NVIDIA Inception is the free program that empowers startups through every stage of their life cycle. Learn how you can fast-track your path to success with these program benefits. Accelerate your growth with credits for technical training, online forums, and expert guidance. Jumpstart your development in the cloud, on-prem, and at the edge with over 150 NVIDIA SDKs, pre-trained models, cloud credits, and preferred hardware pricing. Explore funding opportunities and introductions through the NVIDIA Inception VC Alliance, a community of investors excited to connect with you. Strengthen your startup's visibility through exclusive events, speaking opportunities, and promotional support.
NVIDIA seems to be one of the few, if only, companies building a robust startup program.
No matter what your size or funding stage, NVIDIA Inception can accelerate your growth. Join our global community of innovators today to see what's possible.
I'm such a big fan of Inception. So let me know if you have any questions on Inception or you need to be put in touch with someone on the team. It's a very simple process. You just do a search for NVIDIA Inception program and you apply right on the website, and you should hear from somebody very soon. For everyone out there who's interested in joining the Isaac Sim and Isaac Lab study group, they start in 20 minutes. So you have a chance right now to get a refill of your coffee and then join us on the Discord server and chat with a bunch of community members. Next week at this time will be the Isaac, I believe it's the Isaac Robotics office hours. So you can come and ask your robotics questions for a full hour. So feel free to join that if that interests you. Until then, I hope everyone has a great rest of the day. Thanks for joining us. And thanks again for an amazing presentation by Serve Robotics. Really, really great. And big thanks to Human. Take care, everybody.